Hi all, today we are going to discussing about the module 6 part 2. In this topic, in this session we are first of all we are discussing about the state of transitions. In the low level operation performed, in this low level operations performed in a transaction, there are many states are there. So begin transaction, read or write, end transaction, active state, partially committed, committed, failed state, aborted. So first of all, this begin transaction means it's a marker that specify the start of transaction execution, and the read item or write item, that means the database operations that may be interleaved with main memory operations as a part of the transaction. And the third one is the end transaction, a marker that specifies the end of transaction. And the other one is active state. So it is the first state of every transaction. In this state, the transaction is being executed. And partially committed means in this state a transaction execute its final operation, but data is still not saved to the database because it some failure, power failure or hardware failure, like that. Committed, a transaction here to be committed state, that is a signal to specify that the transaction has been successfully completed in its entirely and will not be undone. That save must be a permanent save. And the failed state, if any of the checks made by the database recovery system fails, then the transaction is said to be failed state. Aborted means a transaction is here said to be aborted, a signal to specify that the transaction has been unsuccessful, and so all temporary changes in the database are undone, and a committed transaction cannot be rolled back. Here this rollback or aborted both are same. Concurrent execution. Here concurrent execution means running side by side or parallelly of transactions. So it has several advantages. Improved throughput, main advantage is improved throughput and resource utilization. That means the number of transactions executed increases in a given amount of time and the processor is utilized properly. And the second advantage is reduced waiting time. That means the unpredictable delays in the running transactions as well as the average response time is reduced. Schedule, it represents the order in which the instruction of transactions are executed. For example, T1, then T2 and T3. That is the order. T1 followed T2, T2 followed T3. There are several problems that occurred in the concurrent execution. First one is lost update problem. In this problem occurs when two transactions that access the same database items have their operations interleaved in a way that makes the value of some database item incorrect. That is, successfully completed update is overridden by another user. That is the problem. For example, T1 transaction that initially the account contain 1000 rupees and read the data value that 1000, that data item reads 1000, and then he withdraws, the T1 transaction withdraw 50 rupees from an account with balance, and then the T2 deposits 100 rupee on the same account. He updated it. then final balance would be 1100. When we check the balance, 1100. But what we do in the first transaction, that is a balance that we withdraw the 50 rupees, and then after that in that account 950 rupees only update, but that update will be lost. That is the loss of T1's update. So this can be avoided by preventing T2 from reading the balance until after update. Second problem is temporary update or dirty read problem or write read conflict. In this problem occurs when one transaction updates a database item and then the transaction fails for some reason. The updated item is accessed by another transaction before it is changed back to its original value. And this occurs when one transaction can see the intermediate result of another transaction before it has committed. For example, in T1 transaction, there is a balance in the account original value of contain 100 rupees. That is the balance, and we have updated the balance to 20 rupees, but it aborts. So the balance should be back at the original value of 100 rupees. And the T2 transaction read the new value of the balance, that is 120, and uses as the basis of 10 rupee as an updation and giving the new balance of 130 rupees instead of 90 rupees. So this problem can be avoided by preventing T2 from reading the balance until after T1 commits or aborts. Unrepeatable read or read-write conflict. In this transaction, this problem occurs when a transaction gets to read unrepeated, that is different value of the same variable in its different read operation even when it has not updated its value. So if a transaction Ti reads an item value twice and the item is changed by another transaction Tj in between the two read operation, hence the Ti receives different value for its two read operation of the same item. For example, database contain or account contain 1000 rupees for A. The item T1 transaction reads the item A as 1000, and in the T2 transaction also read the value of A 1000 and then updated the value of A as 1000 to 2000 plus 1000, that gives a 3000 value, and it is in the buffer, and that can write into the database. Now again the T1 transaction read the value of A, but now the value of A is 3000 rupees, and that is for before T1 reads the value as 1000. After some time the same database item same item can read as 3000. That is the problem of unrepeatable read problem. Incorrect summary problem. In this problem, if one transaction is calculating an aggregate summary function on a number of records while other transactions are updating some of these records, and the aggregate function may calculate some values before they are updated and others after they are updated. And it occurs when transaction reads several values, but second transaction updates some of them during execution of the first. For example, there are two transactions T1 and T2, the two variable data items A and Y. For A, the value is 100 and Y, the value is 200. Before transaction and after transaction should be consistent, so A plus Y is equal to 300. So after and before it should be consistent. We check. So the T2 transaction sum is equal to 0 and read the database item A and its value is 100 and sum is equal to sum plus 100. So sum is 0 plus 100, that will update as 100. Now the sum value is 100. After that T1 transaction read the Y item. Y item, when it is read the database, in database the Y value is 200 and read and updated Y plus 100. Now the Y value updated as 300 and read the Y write the Y into the database as 300. And again the T2 transaction occur, read the Y value. Now what is the Y value? Now 300 is the Y value. So that value can be read from the database and now updated the sum value, sum plus Y. So sum plus Y means now the sum value of database sum is 100 and the Y is become 300, that become 400. So after and before transaction we know it should be consistent. So A plus Y before transaction is 300 and after transaction Y value is what? 300 plus, and what is the value of A? 100. So 100 plus 300, 400. 400 and 300. So it is inconsistent. That is the incorrect summary. As a schedule, as the name suggests that it is the process by which a process of lining the transaction and executing them one by one. When there are multiple transactions that are running in a concurrent manner and the order of operation is needed to be set so that the operation do not overlap each other. Scheduling means a schedule S of n transactions T1, T2, Tn is an ordering of operations of transaction in a chronological order. T1 follow T2. So in T1 read operation is performed and after that T2 write operation is performed. So when several transactions are executing concurrently, then the order of execution of various instructions is known as schedule. Here the types of schedules is two types, serial and non-serial or concurrent. Serial schedule, in this schedule in which the transactions are executed non-interleaved, that is a serial schedule, is one in which no transaction starts until a running transaction has ended, are called serial schedule. For example, T1 followed T2. So in the database A value is 100 and read the data value as 100 and then updated with 50. Now the value of A is 150 and write that into the database. Again the T2 transaction read the database item. Now the database item of A value is 150 and updated with the 100, now become 250 and write into the database database. Now the value of A is 250. So this one is T1 followed T2. Here this is a serial schedule since the transaction performed serially in the order T1 followed T2. So the same case in the T2 followed T1. And the non-serial schedule, that or a concurrent schedule, is a type of scheduling where the operations of multiple transactions are interleaved and it might lead to a rise in the concurrency problem. And the transactions are executed in a non-serial manner, keeping the end results correct and same as the serial schedule. Unlike the serial schedule, when one transaction must wait for another to complete all its operation in the non-serial schedule, the other transaction proceeds without waiting for the previous transaction to complete. And this sort of schedule does not provide any benefit of the concurrent transactions. Here T1 and T2. So the database item A value is 100 and read that value and updated with 50. Now the value of A is 150. Now the database item is not as 150. Now itself a database item is because the write operation is not yet performed. The T2 transaction read that value, that means A value is now 100 and updated as with 100, then now the A value is 200. And the T1 transaction write operation performed, on that time the value of A is 150 and written as 150. After that T2 transaction also perform the same write operation. Now the value of database item is 200, but so the database can now become inconsistent state. So that is the problem. So we need to discuss serializability. That means when this non-serial schedule can be divided further into a serializable and non-serializable. So here serializability means when some non-serial schedule may lead to inconsistency of the database, and serializability is a concept that helps to identify when a non-serial schedule are correct and will maintain the database consistent. Serializable schedule. This is used to maintain the consistency of the database, and it is mainly used in a non-serial schedule to verify whether the scheduling will lead to any inconsistency or not. On the other hand, a serial schedule does not need the serializability because it is already a serial schedule, because it follows a transaction only when the previous transaction is complete. The non-serial schedule is said to be serializable schedule only when it is equivalent to the serial schedule for an n number of transactions. Since concurrency is allowed in this case, thus multiple transactions are executed concurrently. A serializable schedule helps in improving both resource utilization and CPU throughput. For example, here in this T1 followed T2. So this is a schedule. In T1 read and write operation performed. After that the T2 also the read and. This is a serial schedule. So it doesn't need any serializable. So in the second case below that, a parallel schedule is performed. That is, in T1 transaction first read operation, in the T2 again the read operation, then write operation, after that write operation. So T1 then T2 and after that T1. So there is a loop. If there is a loop occur, then it became a parallel schedule. So it is not a serializable. So now it is, if it is a parallel schedule, it is not a serializable. So we need to serializable. So in order to that, we have to do many operations. One time we have to the write operation can be performed the previous in the after the read operation. That is, in the T1 transaction, first it can read that item. After that, write operation should performed. Both these operations completed, then only the T2 transaction started, then read and write. So now there is no any loop, so it becomes serial schedule. That is a serializable. Conflict serializability. It is one of the type of serializability which can be used to check whether a non-serial schedule is conflict serializable or not. A schedule is at conflict serializable if we can convert into a serial schedule after swapping its non-conflicting operations, and the two operations are said to conflicting if all conditions satisfies. That is, they belong to different transactions, first one, and they operate on same data item the second one, and third one, at least one of them is a write operation. Conflicting operation can be checked. For example, check the conflict pair in another transaction and draw the edges. With the help of the precedence graph, conflict serializability can be checked. So this serialization graph or precedence graph is used commonly to test conflict serializability of a schedule. So in this it is a directed graph vertices V and E consisting of a set of nodes V, T1, T2, T3 and Tn, and set of directed edges E, E1, E2, E3 and En. The graph contains one node for each transaction Ti, and edge Ei is of the form Tj followed Tk, where Tj is the starting node of Ei and Tk is the ending node of Ei. So, an edge Ei is constructed between the nodes Tj to Tk if one of the operation in Tj appears in the schedule before some conflicting operation in Tk. So, here in this transaction, the conflicting pairs are read write, write read, write write. So first that T1 read operation, the data item is X, and that checking the write. What is the conflicting pair? Write. Write X. In T2 write X is there? No. And in T3 write X is there? No. So there is no conflict. That operation is already checked. And second one is T3 in T3 read Y. Y is the data item. What is the conflicting pair? Write Y. Write Y is the in T2 is there? No. And T1 no. So that is also not a conflicting. That we also checked. Read X. Read X. What is the conflicting pair? Write X. Write X in T2 no, and T3 yes. So T3 to T1. So the precedence graph T3 to T1 we need to write, and that is we are T3 to T1, and then what we are checking, T2 transaction read Y. In read Y, what is it? Write Y is the conflicting pair. In T1 write Y is the no, and in T3 write Y is the yes. T2 to T3 is the another one. T2 to T3. T2 to T3 means T2 to T3. So we are connecting these vertices, and then what? Read Z. What is the conflicting pair? Conflict pair is write Z. Same we are not checking the same transaction. Other transaction we need to check. Write Y is there in T1? No. Write Y is there in yes in T3 is there. Write Y. So write Y is there. So then write Y T2 to T3. T2 to T3 we've already mentioned. And read Z. Read Z means Z. Write Z is the another transaction. Write Z is there T2 to T1. Then what? And then T3 write Y. So what is the two transactions for write operation? Read and write conflict pairs are there. Is there any T2 read Y? No. And T1 also read Y is not there. So after that there is no any other operation. It's over. That we are already checked. So there is we have to check the loop or cycle. In T1 to there is no any arrow or edge. So T2 to T1 and T2 to T3 and T3 to T1. So there is no any loop or cycle. That's why it is a conflict serializable. If it is a conflict serializable, then we need to check whether it is a serializable. There are several transactions T1, T2, T3. For if there is a 3 transaction, then 3 factorial is the number of transactions that may occur. From that, one of them may be a serializable, serial schedule. So we want to find out the which schedule is the serial schedule. So in order to that, we need to check the in degree. In degree 0. In degree 0. So here the T1, the in degree is 2. It is not that. T3 1. And the in degree of T2 is 0. So first we have to take T2. After removing this T2, we have to check the in degree of T3. That's also 0, in degree 0. Then T3 we have to taken out, and then final one is T1. So T2 follow T3 follow T1. Now this schedule is a serial schedule and it is a serializable. So if whether it is a serializable, that state must be a consistent state. Thank you.